So the last type what you have is your split Manchester type, okay? So the past spectral density of split Manchester format. So we have to proceed by all the previous steps which we have followed. So you know that if symbol 1 is transmitted, if this symbol 1, 0 in the case of split Manchester, how is the signal transmitted? So if it is 1, you have it to be plus A2 minus A. Okay, so this will be TB by 2. So the whole duration is TB. Okay, so if it is 0, it is minus A2 plus A. Okay, so this is how your, again if it is 0, it is minus A2 plus A. It goes on. Okay, so we can write that AK is equal to, if for symbol 1, it takes the value A for 0 to T less than TB by 2 and minus A to TB by 2 less than or equal to TB. Similarly for symbol 0, it switches from minus A to A. Minus A for 0 to TB by 2 duration and A for TB by 2 to TB duration. And you know that, so in the lecture 8 we have seen that in the case of unipolar, bipolar, polar, you have the same formula, that is TB into zinc FTB, whereas in the case of split Manchester, your formula for V of F is equal to TB into zinc. So here it is not pi FTB, it is zinc FTB by 2 into sine pi FTB by 2. Okay, and you have seen the general equation is equal to, that is the past spectral density as x of f is equal to a square into TB into zinc square. Okay, here also it is FTB by 2 into sine square pi FTB by 2. Now you are going to prove this one. Okay. So at the end of this video, I'll explain you how you are obtaining this V of F as TB sync FTB and TB sync FTB by 2 and sine pi FTB by 2 also. Okay. So we have written it here directly. V of F is equal to, here V of F is equal to, here you will be getting a J. Okay. J also will be there. So when you take magnitude of V of F, you will be getting it as, so TB into sync, here it is FTB by 2 and sine pi FTB by 2. So what will be your magnitude square is equal to TB square into sync square FTB by 2 into sine square pi FTB by 2. Now you have got VF. What is your next step? The second step is to find out your autocorrelation function, right? So you know that in general the autocorrelation function RA of n is equal to expectation of AK into AK minus 1. What are you going to assume? You are going to assume that the probability with equal probability, right? So the symbols occur with equal probability. That is probability of AK is equal to symbol 1 is equal to probability of AK is equal to symbol 0. It has equal probability, so it will be equal to 1 by 2. Now we are going to take the same case 1, when n is equal to 0. What will be your value? RA of 0 is equal to expectation of AK into AK minus 0, that is AK. You will be getting expectation of AK square, right? Now if you take the data, for n is equal to 0, you have to bit, right? That is 0 and 1. The data will be 0 and 1. If it is symbol 0 is transmitted, what are the combinations you have? For 0 itself, you have two combinations, right? Minus A and A. So AK is equal to, you are going to replace the 0 by minus A for first case. So minus A, and second case you are getting it as AA. So what will be your, for both the cases it is going to be A square and A square. Similarly for symbol 1, what you have? A to minus A, right? So what you will be getting? A and minus A minus A. So in this case also, both the cases it is A square, minus A into minus A, it is A square. So together I have taken it. Okay, for symbol 0, A square, here also it is A square, both the cases. Now what will be the together probability? The probability of symbol 0 and 1 is equal probability, which is equal to 1 by 2. So what will be your AK square into, what will be your expectation of AK square, which is equal to A square into 1 by 2 plus A square into 1 by 2. So RA of 0 is equal to A square. Now you have got your first value. Now you have to find out case 2. Case 2 when n not equal to 0. So when n not equal to 0, what you will be having? RA of n is equal to expectation of AK into AK minus n. So what are the different combination you have for n not equal to 0, it can take, the data can be 0, 0, 0, 1, 1, 0, 1, 1. So for this case, 0, 0, we are replacing it by 0, minus a, minus a, minus a minus a, and a minus a. So here in this case, you have two possibilities, right? Means two durations, 0 to tb by 2 and tb by 2 to TB. Okay, so you are splitting into two different cases. So totally you will be having so minus a, minus a, minus a minus a, and a. So this will be equal to a square. Here it is minus a square, and a square. So and for the next case, 0, 0, 0, 1, 1, 0, 1, 1. Now you are going to replace 0 by a. So a minus a, minus a minus a. So if you see this, you can, it is clear that here it is a square, here it is a square, here it is minus a square, minus a square. Similarly, a square, minus a square, minus a square, a square. So ultimately what will you get? When you multiply it with the probability equal probability, right? Everything will be cancelled off. Your value will be equal to 0. So R A of n is equal to 0 for n not equal to 0. So this is ultimately looking similar to that of your polar non-return to 0 form. So this is one more clue. R A of n is equal to a square for n equal to 0 and 0 for n not equal to 0. You have got the value for R A of n. Now can you substitute it in your power spectral density formula? So S x of f is equal to 1 by Tb into Vf, magnitude of Vf square, summation n is equal to minus infinity to infinity R A of n into e power minus j2 pi fn Tb. Instead of V of f, you are going to substitute Tb, Tb square, sin square, here it is ftb by 2 into sine square pi ftb by 2. Now you have only one value, right? So R A of n, for n is equal to 0, you have a square. For the other case, it is 0. So you can have only one factor, R A of 0 into e power 0, which is equal to 1. Instead of R A of 0, you are substituting the value, it is a square in the next step. So what you will be getting, Tb into sin square into pi, here it is ftb, okay? ftb into sine square pi ftb by 2 into a square. So what will be your final formula? S x of f is equal to a square into tb into sin square ftb by 2 into sine square pi ftb by 2. So this shows you the diagram. You can see that the bandwidth lies between how many? 0 to 2 by Tb. So it is twice that of your bandwidth of your bipolar, polar, unipolar formats. Okay. Most of the power lies inside the bandwidth 2 by Tb. That is twice as that of the non-return to 0 all other formats. Okay. So before finishing off, let me now explain how you are getting these two signals, that is V of f is equal to Tb sin ftb by 2 for the case of three cases, unipolar, bipolar, polar, non-return to 0, and V of f is equal to j Tb into sin ftb by 2 into sine pi ftb by 2 for split Manchester type. Okay, so let us consider the first type, that is, so this is just for your understanding. For first type, if you take it is for all the non-return to 0 type, right? So if you take the signal non-return to 0, you will be getting it from 0 to Tb, right? Your data will not return to 0 for the entire bit duration. So 0. So if I can, this is, if I can redraw it, it is equivalent to a rectangular pulse, right? Where you have minus Tb by 2 and this as plus Tb by 2. So if you apply, so I can take this as your rectangular pulse. V of t is equal to rectangular t by Tb. Okay. Now if I take this Fourier transform, we will get the signal, right? V of f is equal to, so what is your general formula for Fourier transform? Minus infinity to infinity V of t into e power minus j2 pi ft into dt. Okay. Now you are going to apply your limit. In this case, it is minus Tb by 2 to plus Tb by 2. Your value is amplitude, I am taking it as 1. Okay. So 1 into e power minus j2 pi ft into dt. Okay. Now you can apply your limit. So e power, just apply the integration. ft divided by minus j2 pi f, right? What will be your limit? Minus tb by 2 and tb by 2. Okay, so now if I can take this minus j2 pi f outside, okay, 1 by minus j2 pi f, you can apply your limit, right? T, instead of t you are going to apply the limit tb by 2 minus j2 pi f into tb by 2, right, minus e power minus j2 pi f t, sorry, f into minus tb by 2. Okay, this is what you will be getting. Now this 2 get cancelled, here 2 will get cancelled, minus into minus it becomes plus. So 1 by minus j2 pi f into e power minus j pi f tb minus e power minus j, sorry, plus, right, minus into minus, so j pi tb f, right? Here you will be having one f. Now you have got e power minus j pi f tb minus e power plus j pi f tb. So now you know that sine theta formula, you know, right? So sine theta is equal to e power j theta minus e power minus j theta divided by 2j. Can we simplify or configure this into this form? So what you will be getting, v of f is equal to, I am going to make this 2j, I am going to bring it inside. Okay, so what you will be getting, I can just, and this minus, if I take it to the numerator, what you will be getting, 1 by pi f. So here it will become e power j pi f tb, right, minus e power minus j pi f tb divided by 2j. So I can replace this by sine theta. So what is your theta? J theta. Theta is equal to pi f tb. So what you will be getting, 1 by pi f into sine pi f tb. Okay, so this is what you have got. Now your answer is in sync, right? So you know that what is your sine pi theta divided by pi theta is equal to zinc theta. Okay, this is your formula. So if I want to get pi theta, theta is equal to f tb, right? So here you have to multiply and divide by tb. So what you will be getting, tb into sine pi f tb divided by pi f, you are multiplying by tb, sorry, you are dividing by tb. So this I can replace it by zinc theta, right? So you will be getting tb into zinc, what is theta? F into tb. So now this is your value, v of f. When you take a rectangular pulse, you are getting it as tb into zinc f into tb, which is nothing but your first formula, right? tb into zinc f into tb, which is for unipolar, bipolar, polar, non-return to 0. Okay. Similarly, if you see your next for Manchester, split Manchester, what will be your signal? Your signal will be taking, right, plus a minus a for your time duration 0 to tb by 2. So this will be your, sorry, 0 tb by 2 tb. So I can write this equivalent, if I shift, I can write the signal just like this. Okay. So what will be your limit here? tb by 2, 0, tb by 2. So v of f will be equal to, you have two limits, right? So you know that general formula. In the general formula, now you are applying two limits. So what will be your expression? Minus tb by 2 to 0. The value is equal to 1. So 1 into e power minus j2 pi ft into dt plus, again you have 0 to tb by 2. tb by 2, here it is, the value is minus 1. So minus 1 into e power minus j2 pi ft into dt. Okay. So if I can integrate and apply your limit, what you will be getting, e power minus j2 pi ft, right, divided by minus j2 pi f. Limit is minus tb by 2, 0, minus, right, here it is minus 1. So you will be getting minus again e power minus j 2 pi ft divided by minus j 2 pi f. What will be your limit? 0 to tb by 2. Okay, tb by 2, correct. Now you can apply your limit. Before that, can we take this as common? Minus j 2 pi f. So if I take this as common, minus j 2 pi f, then if you apply your limit, e power, first limit is 0, right? E power 0 is equal to 1. So you will be getting 1 minus e power minus j 2 pi f into minus tb by 2. So it will become plus. Okay. So this is your first limit minus. Here also you have e power minus j 2 pi f into tb by 2 minus e power 0 is equal to, what is your value? It is equal to 1. So you will be getting like this. So here 2 will get cancelled. Here also 2 will get cancelled. So you can write that minus 2 pi f into 1 minus e power minus into minus plus, right? So j pi f tb, okay, minus e power minus j pi f tb, minus into minus, it is plus 1. So 1 plus 1, it is 2, right? So you can write 1 by minus j 2 pi f, 1 plus 1, 2. So 2 minus, if I can take this as minus as common, e power j pi f tb plus e power minus j pi f tb. So how can you write it? It is e power j theta plus e power minus j theta. Can I write it as your, configure it as cos theta? Okay. So what will I get? 1 by minus j 2 pi f, 2 minus, so here it is cos theta is equal to e power j theta plus e power minus j theta divided by 2, right? So I can write it as 2 cos theta. So 2 cos, what is your theta? Pi f tb. So here I can take 2 as common, right? If I take 2 as common, this 2 and this 2 will get cancelled. So again you can simplify it by 1 by minus j pi f into 1 minus cos pi f tb. So since you have to convert it into sine square theta, you know the formula, 1 minus cos 2 theta is equal to 2 sine square theta, right? So here it is 1 minus cos theta. Okay, so here if you can reconfigure it, what will you get? 1 by minus j pi f into 2 sine square theta. What is your theta? Pi f tb. So pi f tb you have to divide by 2. So now you have to, here it is sine square, right? Now I am going to separate it sine into sine, because you have one as sec and the other is sine, right? So you can write it as, now just writing the formula once again, v of f is equal to 1 by minus j pi f into 2 sine square, I have written it separately, sine pi f tb by 2 into sine pi f tb by 2. Just here now we are going to reconfigure, okay? This j I am going to take it to the top. So if I multiply and divide by j, what you will be getting? J divided by, you will be getting j by pi f. If I bring this 2 down, then I will be getting pi f divided by 2. Here you have a tb, right? So multiply and divide by tb. Okay. So you will be getting sine pi f tb by 2 into sine pi f tb by 2. Okay. Now just bring this pi f tb by 2 here. So what you will be getting? J into tb into sine pi f tb by 2 divided by pi f tb by 2. Okay. Into sine pi f tb by 2. So you know that sine pi theta divided by pi theta is equal to sin theta. So you will be getting j into tb into v of f is equal to j into tb into, what is theta? Theta is equal to f tb by 2. Okay, so you will be getting sin f tb by 2 into sine pi f tb by 2. So this will be your equation, what your generalized equation what you have got. Okay, j into tb into sin ftb by 2 into sine pi ftb by 2. So when you take your magnitude square, you will be getting j as 1. Okay. So you will be getting tb square zinc square ftb by 2 into sine sine square pi f tb by 2, which you are going to substitute. So this is just for your understanding how you have got both the v of f.